Hi, welcome back to the class. So last week we talked about introductions to chemical process plant design, and this week we're going to talk more biological class about toxicology. Because of the quantity and variety of chemicals that we use in chemical process industry, so as engineer we need to know a few things. First, how the toxicants enter our body, and how does our body purge this toxic, and what is the effects of these toxics on our body. And the last one is the method to prevent or reduce the entry of toxicants into our body. So number 1 to number 3 are related to toxicology, and the last areas is essentially industrial hygiene, a topic to be talked about in the next chapter. Many years ago, toxicology was defined as the science of poisons. However, the word poison itself cannot be defined adequately. For example, a very harmless substance such as water can be fatal if it's pumped into a biological body in a very large dosage. So a fundamental principle of toxicology is there are no harmless substances, only harmless ways of using substance. Today, toxicology is more defined as a quantitative and qualitative study of the adverse effects of toxicants on biological organisms. So this toxicant we are talking about can be a chemical or a physical agent. This toxicant that we are talking about include the chemical and physical agents such as dust, fiber, noise, and radiation. A good example of this physical agent is asbestos fibers that can cause lung damage and cancer. Toxics can enter our body through a few routes. First is injections by eating or drinking. Second is inhalations by breathing through your nose or the mouth. Third is injections through the cuts into the skin. And number 4 is what we call the skin absorptions through your skin membrane. All these entry routes are controlled by the applications of proper industrial hygiene techniques as summarized in Table 2.1. And we are going to discuss more details on this control method in the next chapters on industrial hygiene. The skin play an important role in both dermal absorptions, or we call the skin absorptions, and injections route of entry. Injections include both absorptions through cuts or mechanical injections through a needle. The skin itself is composed of an outer layers of dead, dry cells that are actually resistant to toxicants. Absorptions also occur through the hair follicles and sweat glands, but this is normally negligible. The absorption properties of the skin varies as a function of locations and the degree of hydration. So the presence of water increases the skin hydrations, and it actually results in increased permeability and absorption. So most chemicals are actually not absorbed readily by the skin. Only a few chemicals shows that it can actually penetrate through skin. For example, phenol. I know some of the students, when they come to their semester 7 or semester 8, they use phenol as part of their chemical FYP project. So phenol, for example, require only a small area of skins for the body to absorb an adequate amount that results in death. So if any of you are dealing with phenol in the future, please be careful. Now we come to a bit of biological class here. We're going to talk about the respiratory system because this respiratory system play an important role in toxicants entering the body through inhalations. And as you can see from the slides, the respiratory system are divided into two. One is the upper and the other one is the lower respiratory system. The upper respiratory system consists of your mouth, your nose, your sinus, all the way until before the lung. And lower respiratory system is where it consists of your lung and all its smaller structures such as bronchi and alveoli. The upper respiratory tract is responsible for filtering, heating, and humidifying the air. Fresh air brought in through the nose is completely saturated with water and regulated to the proper temperature by the time it reaches our lung. The mucus lining in the upper respiratory system helps in filtering dust. So both the upper and lower respiratory tracts respond differently to the different type of toxicants. Over here, the upper respiratory tract is affected mostly by toxicants that are water soluble. This material either reacts or dissolves in the mucus to form acids and bases that can cause our nose to have acid or base alkaline burn. Toxicants in the lower respiratory tracts affects the alveoli by physically blocking the transfer of gases. A very good example here is the haze particle. Certain size of the haze particles can be blocked by our nose mucus, but smaller than that, those insoluble dust, they actually physically blocking the transfer of gases by getting into the lung, into the alveoli, but it just gets stuck there. It makes the alveoli becomes a filter. Or the other toxicants is where it reacts with the wall of the alveoli to produce corrosive or toxic substance. There's an example given here, which is phosphine gases. It reacts with water on the alveoli wall to produce HCl and carbon monoxide. This figure shows the expected blood level concentrations as a function of time and route of entry. The blood level concentration is a function of a wide range of parameters, so large variations in this behavior are expected. And as you can see, injections usually result in the highest blood level concentration because it is direct. And the next one followed by inhalation, ingestions, and the last one is dermal absorption. So far we have been talking about how the toxicants can enter our physical body. But right now, the next few slides, we're going to talk about how our body purge out these toxicants. There are a few ways: by excretions, through the liver, kidney, and lungs or other means, or by detoxifications or storage. The kidneys are the dominant means of excretions in our human body. So the toxicants are extracted by the kidneys from the bloodstreams and are excreted in the urine. So toxicants that are ingested into the digestive tracts are normally being extracted by the liver and be purged out from our body through our stools. And lungs, also another means of eliminating substance, especially volatile substance such as chloroform or alcohol. There are also other smaller routes of excretions, be it from the skin by sweat or hairs or nails. These routes are usually minor compared to the excretion process of kidney, livers, and lungs. So the next process is the detoxifications. The liver is the main organ in this process, where the detox starts by biotransformations that transform chemicals into something less harmful or completely harmless. It can also occur in other organs like blood, intestinal tracts, wall, skin, kidney, and other organs as well. The final mechanisms for eliminations, I don't call these eliminations, but it's a way of the body to cope with toxin, is by storage. So this process involves storing the chemicals, agents in the fatty areas of our body. So sometimes you may hear people say when you are in a toxic environment, you start to grow fat. Actually, this is true. So what happened is that when our body couldn't process fast enough to get rid of the toxic, be it we overload our liver or kidney. So what happened is the body just decided to store it because it doesn't know what to do with that. And this actually can cause a future problem if one day this person decide to say, okay, I want to cut some fat, and he start to exercise or he start to cut down a food intake. So the moment this fatty area is being metabolized, what happened is that the toxin that's been encapsulated within has been released back to the body. So that also explains why sometimes after a while, if you did not exercise and the moment you start to get back into exercise, you feel so awful because of the toxins being released back to your bloodstreams that causes you to feel very lethargy or it's just a bad feeling. And that explains it. With this, it concludes the part 1 of today's class to talk about how toxicants enter the body and how toxicants being eliminated from the body. So the second part of this lecture will talk more about the effects of toxicants on the body and also how we do toxicology study that involve lots of calculations. So enjoy!